Hello, this is Herein from Quick Analytics. Today we are going to learn how to perform data wrangling with dplyr. So let's get started. First, we need to create a R Markdown file, and you can give the name or you can leave it like that. It's good to give it a name. Since we are doing data wrangling, so we are going to say data wrangling, or let's say data transformation with dplyr. And so the first part of the document is called the YAML, and it has the title, the name of the author, and the date, and the output type. So the default output type is HTML, but we can also output our data or result as a PDF or Word document. The next, we need to save our file. We will save it under R. These are the scripts. And so we'll say data transformation. And then we don't need everything else there. So this part here is the global setting. And what I will do, I will modify it so that we will say here we are loading the libraries, and we will come inside here, add two more options. Message to suppress messages, we will set it equal to false, and then warning to suppress warnings, set it to false, and then line it up. And then after that, we are going to add the libraries that we are going to use. First, we will load tidyverse, and then read Excel, because we are going to work with multiple Excel sheets. So tidyverse has about 8 packages: dplyr, tidyr, forcat, ggplot2, purrr, and stringr, and so on. Now let's run this. So we can run it by using the play button, or we can click anywhere and then comment on Mac, comment return, but that will do one line at a time. It's control return on a PC. Then after that, or next, we will load or we import the data. And so I'm going to do on the Mac, there are two ways we can insert the code chunk. We can come here and insert it by clicking R. You can see here there are other languages. Or you can do Option Command I, which is Control Alt I on a PC. And so we are importing the data. We will give it a name, path, and then we will use the dot to go to the next level, like the level of the data file. And multiple Excel sheets is what we want, multiple sheets. Then enter, and we can see it here. We have read it in here. Now it's accessible within R Studio. and within our Markdown file. So we are going to give our data set a name of a file, the name. So we will call it SS for South Sudan underscore 2018 census. And maybe we will call it raw for the raw data before we clean it. And then now path. To enter the piped on PC, use on Mac, use Shift Command M, or on PC is Shift Control M. Since we are working with multiple sheets, there's a function in readr called Excel underscore sheets that loop through the sheets. And then there are times when we need to keep the name of the file, name of the sheet, because each sheet has a name. Sometimes they might be just like positioned by numbers, indices, but here in our data set, we have given each sheet a specific name, which is the name of the state. So we will use set underscore names to set the name of each file, each sheet. And then now, instead of using for loop to loop through each sheet, we are going to use this function from purrr, which is map underscore df, which is for the data frame. And we need to input the function. The function is read underscore Excel. And then we need the path. The path is equal path. And then we need the ID. And here we will call the ID, we just call it file name. For our data set, ID is not important because we have in the data set itself, there's a column for state names, but I'm including it here so that you understand how to add it. Now let's run it. What I have done is just click anywhere here and then comment returned. And now we have our data set read in. We have read in our data set, and we can see that it has 450 observations or rows and 12 variables or columns. And when we click on it, we see that this is the ID that we added, but the same ID is here under the region name, which is the states, except this is saying lakes, but there we are saying lakes state. It's the same thing, whether we say lakes, that is a state, or we just say lakes state. So this is not actually, this column is not necessary. And so it's important, or it is imperative, to have a better understanding of your data set before you work on it, before you clean it, so that you know which columns and which rows to include and which ones not to include. For our case, we will include former region. There are 3 former regions in South Sudan: Greater Bahr el Ghazal, Greater Upper Nile, and Greater Equatoria. And these 3 regions were divided into 10 states when South Sudan signed a peace agreement that resulted in the independent South Sudan. And then we will keep the region name, which are the names of the states. We will keep the variable name, which is the column that contains rows for population roll-up in each state, and gender rows, that is male and female, and an age name for the age group or age categories, and then the population itself, which is 2008. There's another function that we could have used called to view the data instead of opening it. So we could have run it like that and it would have opened it like this. but it is optional. I don't usually use it. I just click on the file name in the environment and then view it. Now, okay, so that's it there. Next, what we need to do now is the data transformation. We can subset the data by calling it, giving it the extension table. Table is the modern data frame. And then we call the file with the raw data. We can look at the data structures by using the glimpse function. And when we do that, we will see here that, okay, our data set has 450 rows or observations, 12 columns or variables, and then the data type for each column. So all the data types, all the columns here are of the character type, except the population column, which is doubled, which is the same as numeric or integer. So these are numbers, because those are population counts. Another thing we will notice here in R, when a column name is made up of more than one name, then you have, like, for example, file name has been closed in between backticks. And also when the column name is a number, it's also enclosed between backticks. So that is important. Before we do this one, let's inspect the first few rows and the last few rows. So so there's a function called hit that we can use to do that, to look at the first rows. If we do it like this, and then it will give us the first 6 rows, and we'll be able to have like a quick understanding of our data set, whether there are missing values on the top or not. To comment a line out, you use Shift Command C. I like using slice underscore hit, which was released when with dplyr 1.0.0. It's the same as it, but here you have to specify the number of rows that you would like to see. If you don't specify the number of rows, you will get only one row. So it's doing the same thing. And then let's look at the last few rows, maybe 10. And so there is a function tail that we can use in base R, and it will tell us what is going on the bottom of the data set. But I like using slice underscore tail, which was also released with dplyr 1.0.0. You have to specify the number of rows that you would like to see to print out. Okay, then There's another package called schemr, which can be used to perform a quick summary of your data to see if there are missing values and different data types. So our data set is this. So let's say, for example, we subset it like this. Then we pipe it into a schemr, but because I have not loaded a schemr package, so you can call a function from a package without loading it completely by writing the package name and then colon, and then the function that you want to use, and then you run it, and then now printing this out, we will see this is the summary of our data set. So summary, then the name, the values, and it is pipe data. Number of rows, 450, number of columns, column type, frequency. So character, there are 11 columns of character type, and there is only one column of numeric type. Then grouping variables, none. And we see here, so this is the summary of these. And it first is those columns that are of character type, and it is showing us missing values in each column, and as a percentage, as a count, and as a percentage, and the minimum, and so on. And then the last one is the numeric, and the numeric columns are summarized using the 5 number summary, which is mean, or actually let's say mean, standard deviation, and then the percentiles like P1, percentile 0, which is the minimum, percentile 25th percentile, which is the 25th percentile, and then 50th percentile, which is the median, and then the 75th percentile, and then the 100th percentile, which is the maximum. So these are the 5 number summary. And then there is a histogram here, which means our data is skewed. So briefly, that is what schemr can do. It is an important package that can give you a glimpse of your data summary. Now, let us go into data wrangling. So as we saw here, we have to select the columns that we need to keep, and then we will clean the data after that. So now here, let's say column, select columns of interest. We use the select function from dplyr, and so I will use a glimpse function here. So glimpse, and put in our data set, and I can do it like this so that I can just quickly copy the columns that I want to keep. We can use the indices, the number, the position, or we can use the names. So let's say, so that we want that. Another thing I will do here, we see region name, we see variable name, we see 8 name, and then 2008. So there are select helpers that we can use to speed up our data column selection process. So I'm gonna use one of them saying ends with, and then if it ends with name, and then we will select that. What that will do, it will add also the file name, which we don't want, but that's not a problem. So we can do this one and run it. And then when we come down here, we have selected only 6 columns. And you see here, because we have started with anything that contains name, a column that every column that ends with or in name has been included, and then we are individually selected this column and that column, and this one was included because it has name in it. So that is one way to do it. The other thing we could have done is we could have said select, or let me not do it here, let me create another chunk so that we have a clean data cleaning process. So we could have done it like this. So I'm just gonna override the data there up there. Select desired columns. Select, and then so we would add this one, the first that column there, and then we would say contains, and if it contains name, and finally that column there. And again, it's the same thing, but another thing we could do, since this is a number, we could name it by saying population. So the beauty of select function is that it allows us to rename functions inside, or it allows us to rename columns as we select them. So, and then let's look at it, and now we have changed that. Another thing, we could have selected these columns individually and rename them, but that is, I'm gonna come here and create another chunk, and what I will do is show you that we can rename all these columns. So select columns of interest. So select, we can use their indices or position. So we can say, okay, this is number 2, 3, 4. So 2, so we could have said 2, 4, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 4, 5, 6, 7. And then 7, 8, 9. And then 12. We do this. Now we have only 5 because we have excluded the file name because we have not used a select helper to do that. Now these are the columns that we need. When we do this, we can then rename columns. There are several ways, different ways we can rename the column. But there are 2 main functions. One is the rename. What the rename function allows us to do is rename a specific function. Columns. For example, we can say population is equal, and then we know the last column is 28. And when we do this one, we know now we have renamed it. Another function, because if we want to rename all the functions, then using rename function means that we have to do a lot of typing. So another function that we can use is the set underscore names. And here we need to know the order of the columns. Otherwise, if we don't know and then we set the names, they will be set in that order. So the first one is the region, former regions, former region. So I'm just gonna use the lowercase former region. I'm doing this just to show you that we can do this. And then state. So state, and then let's say maybe population category. Pop category. And then the next one is, I think it's age category. And then population. Now let's run it. If you put just a few columns, if you don't put the exact number of columns here, you will get an error. And now this is what we have. So let's say I didn't, like I accidentally put 4 columns instead of 5. See, I'm getting an error, and it is saying that in set underscore names, the size of nm must be compatible with the size of x. So whatever you put inside the set underscore names must be exactly the same number of columns. That's what it is telling us. So that's not what we want. Okay, so now we are good. But when we see there are NAs under each of the former region, and what we want to do is fill them in, because all these have to be filled with Greater Upper Nile and so on. This is common in Excel. So the function that we will use to fill them in is called fill. And fill is from tidyr, but because tidyr is part of tidyverse, we don't have to call it because it has already been loaded. What you put is the name of the column that we want to transform. We can say 1, but I'm going to put in the column name for my state, for my region, sorry. And the direction that we want to fill it. We want to fill it downward, so we're going to say down, and then run it. Now let's check it. Yeah, it has been filled downward. And so we have solved that issue. Now you can put, if there are several columns that you need to fill downward, then what you can include them as a list. So you can use the C, you can do that, and then add the next column and so on. Oops. Now let's look at our data set. So everything else is good. This column is good. This column is good. But this column is not good because when you see the column is made up of 3 parts. So there is a part with population, comma, and then total, and then inside parentheses number. But when you scroll down, you see the same with male. So what we will do, we will have to split this column into 2 columns. We can split it using the comma, but that will give us 2 columns, but we will have to like Also, you split this. So what I will do, I will split this column using spaces so that we split it into three columns and then only keep the middle column. We will also modify the age category because there are too many age categories, and we will have to manipulate those to reduce the number of categories. Remember, there are no right or wrong number of categories. The right number of categories is the number of categories that will give a good presentation of your data, because you don't want to overstretch your data or compress it within few categories. So modify pop category. To split it, we will use the separate function from tidyr. And what we do, we give it the column that we want to separate is the pop dot category. And what we want to separate it into, for example, the first part we don't want, so I'm just going to say pop. The second part is what we're going to keep, so we will say maybe category. No, I will call it gender, because I will remove the total rows and then leave it as the rows with male and female. And then the last part, we don't mind what it is, so I'm going to call it other. And then there are other options, like if we want to remove the original column or keep it, or if we want to convert these options here, I don't usually use them. Even remove, I always remove it, and it is set to remove by default. We also need to say what is the separator, how we are going to separate it. We are going to separate it by using spaces, and I think spaces is the default setting. So let's run it and see if it's going to work. Now it didn't work. Let's see why it did not work. And it says pop dot category. So that's an error. And now I think it's successful. And yeah, it is successful here. We see these three columns, but we don't need those. We just need the gender column. So we will have to remove those columns. So now next, we will remove the extra columns, and we use the select function to do that. We will say minus. You just subtract them, or you can enter them as a list like that. And now we have removed those. We are back to just 5 columns exclusive. So the next thing to do is the population. We need to clean up the age category. So if we can look at just a single column by using a $sign, and we want the age category. We can look at the unique values, and we can sort them if we want to. And then when we see this, there are, so this year we're going to exclude, but there are 14 of them. So instead of going from 0 to 4, I'm going to go from maybe 0 to 14, and then 15 to 24, So I'm just gonna come here and modify H category column. We will use the mutate function, and the column here is the H category. So let me copy it here. We will use case underscore went from dplyr. So we will say when H category is int, and to say is int, we use the %int%, and then we can give it a list. And so I have said that we are going from 0 to 4, from 0 to 15, so we can copy those, bring them here, and then anything in that range, we will rename it as 0 to 14. And then H category. I'm just doing it here as an example to show how you can create categories and use case underscore went, and then we can go from 15 to 24. And we will call this as 15 to 24. It's good to be careful here, because if you leave out the comma, then you're going to get an error. And as a beginner in R, it can be really frustrating and hard to diagnose or to debug your code. And then we will go from 25 to 34. And 35 to 44. Let's say 35 to 44. And 45. Oh, I see something here. There is also 5 to 9. I'm going to include it in this group. I like to line them up so that I can easily debug them. So 35 to 44. We have done that. So 45 to 54. And then 55 to 64. and there is only 165 plus, but I'm gonna make it at least just to be consistent. We will leave it as it is. We will just leave it like that. Now that leaves us with this here, this column with the totals. So what I'm gonna do here first is so whatever is left over, we just leave it as the column that we want to change. So backtick age category, run it, and then when we run it, this is what we have. And so let me pull out the values so that we see the distinct values before we clean it up. So now let's see, there are 1, 2, 3, 4, 5, 6, 7, 8. There are 8 unique values, but we don't need this. So there are 7 categories, which is a little bit good. So next we need to remove any columns that we don't want. So remove, no, not columns, rows, removed unwanted rows. And so to do that, we're going to use the filter function from dplyr. So we don't want the total, we don't want this total here. We don't want it in the gender column. So we will say gender is, and to negate it, so if we say gender is exactly, so if we say to do the exact, we do the double equal sign. And if we do that, this is only going to give us all the totals here, but that's not what we want. So to negate it, to do the opposite, you do the exclamation point and then equal sign, and that will get rid of those total rows in the gender column. But there is another one here in the age category, so we need to remove that as well. So we come down and say age category, and then we will say we don't want it to be equal total. Then now, and we have reduced our data set from 450 rows to just 280 rows. And this is what we want, but we need to summarize our data again because we have created new age categories and we need to be able to factor that information in. So to do that, we'll say summarization and group by. So we'll group by first. And what are we going to group by? We are going to group by former region, state, gender, and age category, and then just sum of the population counts. So we say former region, state, gender, and then age category. So that's how we would do it, but now we need to sum that row. Another thing we can do, since the columns are in sequence from 1 to 4, what we can do, we can use the across verb from dplyr, and we will only give it the interval. So we will pick the first column and then the last column that we want to group by. And we will do it like this. And then now we summarize. So summarize is population equals sum population. If there are missing values, we can add removed NA equal true, but we know there are no missing values in the population column, so it's not necessary. And then now we have reduced our data set from 450 rows or observations to just 140. We see this message here saying summarized and then as grouping, grouped output by former region, this and this, stage, and override the existing this. So let me see. So what we need to do is we add, there is an option here saying dot group equal, and then we can say drop, drop, and I like to line those up. And then now I have gotten rid of that. So this is our data here. It's a tidy data, and that is how you perform data wrangling. Now, what is left is to be able to visualize it, to tabulate it, and so on. But this is only, I just only wanted to introduce you to data wrangling using dplyr. We have seen a lot of steps that we have created here, but would it not be necessary if we can have a function that we can use to run just only one next time or each time we want the data? So let me copy this, or I will leave that part as part of next time. I'm just going to stop here for now. Please let us know if you have any questions about what we have done, if you have any suggestions, any topics that you would like us to cover, and please don't forget to subscribe